Hello and welcome to our course in Mastering Hybrid Solar System Designs and Feasibility Studies. My name is Hussein Saloom. I'm a doctorate holder in business administration. I'm also an electrical engineer and having a master's of business administration and master's in philosophy of management. I'm also been in UAE for the last 20 years working on energy systems in the manufacturing field, in the integration, smart metering system, and sustainable solutions. So I'm offering this course today about hybrid solar system designs and feasibility studies, which is not a new topic actually. It's actually has been in the market for the last 10 or 20 years, but we are offering this course to equip people with technical knowledge and skills for the latest technologies that fit the solutions in UAE specifically and GCC in general in solar systems and designs. So I would like to inform you that this course is a course of 8 modules, and we are offering it because of the UAE policies in green energy that have been set very aggressively, especially in the last COP28, where it has targeted that 50% of UAE energy by 2050 need to be clean. By 2030, Dubai have set its target to be 25% as renewable and 50% as clean. So all these targets require all of us to be well aware of the sustainable solutions, clean energy solutions, and one of them is the hybrid solar solutions. So this course will go through um, these kind of solutions, starting from the on-grid to the off-grid and to the hybrid solutions, and how to be able to design it properly and make a feasibility study for it to be able to convince the end user or whoever is interested in that to use these kind of systems. So it's a flexible course, but still it's very pinpointed towards these systems and towards the UAE market segment in the commercial and industrial, and it can be applicable as well to the GCC market segments. So I would like to explain that um, these courses spread over 8 basic modules. The first module will start by introduction to hybrid solar systems. The second module will focus on grid systems, how to design it, what are the components, what softwares can be used to do it. The second or the third module will be the designing of off-grid solar systems with the same categories of the components and the software that can be used, which is pretty similar to the on-grid but has some differences in the approach and the calculations. The fourth module will combine both module 2 and module 3 and conclude on the hybrid solar systems, which has different combinations, whether it's an on-grid hybrid solution or an off-grid hybrid solution. In module 5, we will discuss about designing specifically PV diesel generator hybrid solution, which is the most popular hybrid solar solution and solar systems in the country. And in module 6, we will do a commercial feasibility study for these PV diesel solutions, how to calculate the consumption of diesel based on the solar input, how to design it, what are the approaches to use, and what are the best systems to put in place. On module 7, it will be an advanced design consideration module for the PV diesel systems, and it will be more in depth about the automation and the control. And in the last module 8, we will do a practical application for a pilot project, a live case project, or a project that you can also advise throughout the first 7 modules where you can use it and apply it in the 8th module. This course spread over approximately 5 days, 3 to 4 hours per day, depending on the module material, and it's offered as an online or face to face in our Energy Pro Institute located in Dubai. So, today we will start with the first module, which is the introduction to hybrid solar systems. So, what is a hybrid solar system? Basically, a solar energy system is a system that uses the solar energy to generate electricity or heat. So it comprises basically of PV modules, the one that use we can put on the roof or on the ground to get the sunlight, and then we will have the inverters that convert the DC power to AC, and then we can have the batteries as an option in case there is a backup requirement, or we can have a flexibility to store the energy in case of there's excess generator in the PV power, and also monitoring system to control and monitor these energy sources. So the key components we are speaking here is the solar panels, the inverters, the energy storage system, battery basically, and the monitoring system, which tracks the performance and the efficiency. Normally, we divide the systems into three types: grid tied or on grid system, where it's connected to the electricity grid. And this, in case of the excess energy, we can have it exported back to the grid depending on the utility application. For example, in UAE and Dubai, they offer a net zero metering. In other emirates, still in process of applying these uh, policies. But the on-grid applications, you will have the solar panels connected to the grid. In case of the usage by the load, it supplies the load. In case there is less load, we can convert it back or give the excess energy back to the grid. The other type of the system is off-grid system, which is independent obviously of the grid, and this requires sometimes batteries to store the energy in case we are uh, producing more energy from the PV module, or we can combine it also with a generator, but that will be a hybrid system depending on the requirement of the end user. And here we go to the hybrid systems where we combine uh, different, let's say, combinations. It can be uh, you have four sources of power. You have the grid, you have the generator, you have the battery, and you have the solar cells. So these four sources, any of these three available, makes it a hybrid system. So these different systems can be used, and each system have its own approach of design, utilization, and operation. So for hybrid solutions, as we said, it combines solar power with other energy sources like a generator, whether it's diesel or gas, and for battery storage systems. The importance of the hybrid solution is that it provides reliable power even when there is no sunlight, whether there's a cloudy day or it's at night or there is some weather conditions. So the importance of hybrid solution is to give the power a reliable source in addition to the solar source. So it offers continuous power supply, and it reduces, of course, the fuel cost, and it enhances the energy efficiency system. And here we approach the market in the hybrid solution in this region on three levels. First, the utility scale level. It can be on the big scales, utilities like DEWA, Adwiya, uh, Saudi Electricity, Kahrama, etc. Or it can be on the residential level, where the residential applications can be small villas, small buildings, low rise, camps, or certain labor accommodations. And it can be on the commercial and industrial sector. This includes airports, oil fields, data centers, airport applications for, let's say, sewage treatment plants, certain commercial malls, retail centers, etc. So all these applications fall under commercial and industrial sector. In our course, we focus on this segment basically, which is the commercial and the industrial sector, because it has the most suitable solutions that are optimized and uh, well feasible for these applications. On the utility scale, it will be a different approach because it has to be made on a nation level or a country level, which is not the focus of our course. And on the residential side, it's very small and micro kind of applications, which also does not fall specifically in our course category. So, in our approach, we will focus on the commercial and the industrial segment. To start, as we said, power sources can be categorized into four major sources. The first one is the grid, which is a main source. The other one is a generator, whether diesel or gas, and this is also considered as a main source of power. And there's the solar and the battery energy storage systems. Now, for the solar, we don't consider it as a main source because it's a temporary source. It's only a source that's available during the sunlight, certain hours in the day, 4 to 5 hours depending on the location. Sometimes in the cloudy days, it reduces down to 2, 3 hours. So we cannot consider it as a main source. So we consider it as an energy saving source that can save the energy consumed from the grid or the generator. And the third source is the battery energy storage system, which we consider also as a backup source, not as a main source, because this battery will be charged from the main sources or from the solar source and then be used back to the load as a backup. So these are the four more main sources that we will consider in our course. If we go back a little bit in our electrical background to voltage and current sources, this is very important to be able to design and approach our solar systems uh, to know about these types of sources. So, a voltage source is a source basically that provides a consistent and fixed voltage output regardless of the current drawn by the load. And some examples would be a generator, the battery, that are able to maintain a voltage level, whatever is the current rating. So, it maintains it either at 12 volt or 24 volt or 48 volt or 230 volt or etc. And it's very essential to stabilize the output of the voltage to make sure that the system can meet the steady state voltage required by the appliance or the load. So a stable voltage is a need for the load. So this voltage source, as we said, from our four sources that we have discussed before, the generator and the battery and the grid are considered as a voltage source. On the other hand, the current sources provide a consistent current output regardless of the voltage across it. And the major example here is the solar cells. The solar panels behave like a current source, and their output varies depending on the sunlight intensity and the system. And this is very basic in our solar cells. And we will see in the courses ahead how is the panel or the PV module act, acting as a current source. So the current source in this regard is integrated with the voltage regulating devices. Inverter is one of them, to stabilize and convert the variable DC current to the AC voltage for the appliances. As you know that most of our appliances are AC appliances, and the current that's produced by the solar cell is a DC current. So when we have to supply it to the load, we have to do the conversion from the DC to the AC. So in this regard, we have two types of sources, current and voltage, and we are not able to form a grid unless we have both sources in a voltage source and a current source. This leads us to the next slide where we have the inverters that are put in front of the PV modules. One type is a grid type and the other type is a grid forming inverter. So a grid tied inverter basically is a current source, is a current inverter source that achieve the requested power and the reactive power set points. So the inverter here, the grid tied inverter, needs a voltage from the grid. And this voltage will be used to synchronize and to draw the power to the grid. The inverter has the full control over its current. And here it can achieve the requested set points faster as it controls the current directly. In case of failure, the inverter can set its current to the requested values as per the grid requirement. This is the grid type. On the other hand, there's the grid forming inverter. The grid forming inverter operates as a voltage source basically and control the voltage and the frequency of the system. So this inverter will work in parallel with the other generator or the battery or standalone system, and it can also be used in the mode control of the power, the reactive and the passive power, to a given set points. So it will not be only controlling the current, it will be also adjusting its voltage to suit the system voltage. So this grid forming inverter can be used as a voltage source. But however, this inverter will use more PV modules to be able to give the flexibility for this kind of inverter to maintain the voltage levels. So here I would like to conclude that normally, it's better to use grid forming inverter that can stabilize the voltage and make it as a voltage source with the PV modules, and that's especially in the off grid. However, in case you don't have the option to use grid forming inverter, you can use the grid tied inverter, but it has to be always combined with another voltage source like a generator or a grid or even a battery. So this is the importance to know what's the difference between a grid tied inverter and grid forming inverter. Here we come to the hybrid combinations. So based on what we have seen before, we can find two or multiple, but two major categories of hybrid solutions. The on-grid hybrid solutions will be combined with the grid, obviously. So we will have the grid plus the PV module plus the batteries. This is one type of the hybrid solution. The other type is the grid with the PV with a generator, and it can be all of the above. Means it can be the grid with a PV module with a generator and the battery energy storage system. On the other hand, we have the off-grid combinations. We will have the generator and the PV. We will have the generator and the PV as in the off-grid without the grid, so it will form a hybrid solution. It can be also a PV with the battery only, and that will also be a hybrid solution. And it can be generator with a PV with a energy storage system, and that will form a tri-source hybrid solution. But if we have only a PV and cannot be used as a standalone off-grid system without any voltage source, whether it will be the grid-forming inverter or a battery or a generator. So this is very important to know while designing a PV system in the off-grid mode. Otherwise, you have to make the PV so big that it will maintain the voltage of the system within the required limits. So these are the combinations of the hybrid solutions in terms of off-grid and on-grid. Now, what are the benefits that we get from the hybrid solar solutions? It's very important to know that basically renewable energy is to save on the consumption of fossil fuel and to reduce on the carbon emissions, but it has also other benefits. So it provides sustainable, environment-friendly solution. You know, solar system can live up to 25 years, and definitely it reduces on the electricity bills over the time, especially with the increasing electricity bills on the annual basis. It also provides energy independence, and this is very important because in case there is demand on the energy, these kind of systems can give you flexibility and independence on the energy sources. And this, for example, if you have a PV diesel generator, you can put it anywhere in remote areas, on islands, on ships, that can save energy and make you independent from having a grid available. Also, it has a low maintenance cost, of course, with minimal amounts, but it will allow you to find an energy source or to make an energy source with a minimal maintenance costs. So these are the basic benefits of the hybrid solar system. Of course, there's many other benefits. We can discuss it in the due course. What are the challenges that we can find in the hybrid solar system? So there are different types of challenges. We have technical challenges, we have operational challenges, we have let's say executional challenges. So all these challenges we need to know in order to be able to tackle these challenges and resolve it in every project. So we can start with the system complexity. System is complex because sometimes the calculations, when we use like four sources of solar PV and battery and a generator with the grid, sometimes there is a complex calculation that we have to do in order to design and integrate in the best or optimum way possible. So it demands skills and engineers to do these kind of calculations, but that's why we are offering these kind of courses. So these courses will give you the lead and the know-how to design these system that could be looking as complex, but in case you follow the rules or the steps, it will be easy to reach. The second technical challenge we face is the energy storage limitations. So till now, the batteries are expensive. It's more than $200 per kilowatt hour, and this puts a burden on the lifetime of the storage batteries. So that's why we have always to balance the cost against the requirement of the load and the time to supply these loads. So the capacity constraints will lead sometimes to underperform during high demand periods. The third technical challenge is the inverter efficiency. Now, although we have the technology of the inverter is advanced a lot during the latest years. Or still, it's a challenge, a technical challenge, where we need to manage the energy flow between the solar panels, the batteries, and the grid through these inverter control and automation. So you need to know that when you choose your off-grid or hybrid inverter, you choose the one that are really good and these in this sense, and you don't need to compromise on the cost of the inverter for that reason, because the inverter, although its percentage of the cost is less than the other items, however, it's still one of the most important items in the system. So these are the three major technical challenges that we face when having a hybrid solar system. And the cost related challenges, of course, the initial cost or the high initial cost could be one of the major challenges, where the PV, the batteries, and inverters are all substantial compared to only a grid that comes and gives you a bill every month. So that's why a cost or the high initial investment forms a challenge that we need to approach. Also, there could be maintenance cost, especially the hybrid system where there are PV diesel systems, where the diesel generator will need regular maintenance, and also sometimes in case you use gel battery or non-lithium battery, which have long lifetime. So you need to keep maintaining these and ensure that the maintenance costs are well calculated. The third challenge is actually the environmental and climate challenges. So here we speak about the weather changes, the weather variations. It's very important to know where we are designing these systems. What is the weather condition that's affecting the place where we are putting these systems? So sometimes there will be efficiency affected because of the cloudiness or the rainy days, or it could be seasonal variations because of the solar generation. And this is very important when we do a feasibility or a design for a solar system. The temperature, of course, extreme temperatures on the specific, especially in our region in UAE and the GCC, where there could be extreme heats, and this will actually reduce on the efficiency, not increase it. And we need to make sure that we design our systems at certain ambient temperature, like 50 degrees or more, so we don't have derating for the efficiency of the systems. So these are the two environment and climate challenges that we sometimes face in our hybrid solar solutions. Also, there's regulation and policy challenges, and this is obvious because it's an evolving market in terms of the solar systems, where sometimes we don't have any standards or regulations put in place. So we need to ask and find what are the policies or the incentives that are available in the region, because these will affect the cost of the designs or the cost of the system that we put in, whether you are interconnecting with the grid or you are making it on off-grid scenarios. So there could be the sometimes you have the net zero metering that could credit whatever excess energy you produce in the solar. Sometimes it's not available, sometimes it's not allowed, sometimes it's limited to capacity of the system to install a solar system. So all these factors we have to put in our approach for the solar design. Also, there could be some subsidization reliance. Sometimes the government gives some incentives or subsidies for the solar, and this is starting to emerge in our region, and it's very important to put these factors in. I will not discuss much into that part. I will leave it to the specific module of the feasibility studies to discuss these 2 points. On the operational challenges, it's very important to know that energy management, where we manage the solar input with the PV input, with the battery input, is very important in the hybrid solution. It's critical, and it's very important that we are aware how the system will work during the operation, especially when there is a PV diesel generation, where you need to make sure that the generator is running at its minimum capacity. There's a spinning curve, there's sometimes overloading, restraints. So all these factors play a role in the energy management of the hybrid solar solution. Scalability plays a role as well, and it's a challenge in the same place, where expanding the system may be required in some applications. So sometimes you design, for example, a 200 kilowatt or a 500 kilowatt, and you plan to expand later to 1 mega. So you need to take care of these provisions in your initial designs. So these are the challenges that we have seen. Now, to go into the applications that we see that these systems will work in the UAE, the first one is, of course, obviously the remote areas or outside the city site offices. There will be no grid, and it will be very demanding that you use a hybrid solution instead of only depending on diesel generation. Also, there could be temporary labor accommodations, site equipment like cranes and pumps, where you use it during the day, and you can put hybrid solutions for it. Certain special applications like sewage treatment plants, camps, mining power grids, telecom towers, drilling rigs, and wellhead camps, and many more applications can be approached with a hybrid solar solution. And we are speaking here about more than 5,000 construction sites, at least in UAE alone, that can be applying the hybrid solar solution, whether the off grid or even the on grid solar solution. So these market segmentation is very important, and we're speaking only about the commercial and industrial market, where we can offer the hybrid solutions and benefit from its saving on the diesel and its saving on the environment carbon footprints. So this concludes our first module. Let's say this is an introductory module for the course, the 8 module course. And here I would like to go through with you on few questions, which you will of course answer in the end of the course. So first, you have to tell me what's the hybrid solar system, how do you understand it, how many types are there, is there a solar module that what is the source, so what's the solar module, is it a voltage source or a current source, what are the voltage sources, what are the current sources, give me two benefits for hybrid systems at least, give me two technical challenges or operational challenges, and name me two applications that the hybrid system can be used to. So this concludes our first module. Thank you for listening to it, and hopefully that it will be very important and the milestone step towards the next module that we will go through it. Thank you again, and goodbye.